So we have to find the graph, or the graph of the function is shown below, right here, and we have to figure out which of these following statements about this graph is false. So let's just go choice by choice, and we see choice A, f is continuous at x equals a, so we see that, and yep, it's continuous, it just keeps going, so it can't be that. Then we see our answer choice B, x equals a, is the domain of f, and we can see that might be true, but it might not be. And so maybe we'll check this one just to make sure, since we don't know either way. And so our next choice, the limit of f of x as x goes to a from the right is equal to limit of f of x as x goes to a from the left. And this is our limit right here, and it goes, and as it comes from the left, it approaches a, or it approaches this number right here, and as it approaches from the right, we can see that they approach the same number, so that one must be true, so we can cross it off our list. And then we also, our last choice, limit f of x exists as x goes towards a, and obviously we can see that it exists since it's there, so we now know that our answer must be B. We have our function f of x equals x minus 1 times x squared minus 4 over x squared minus a. And so we have to figure out what positive values of a, or for what positive values of a is f continuous for all real numbers. And so because of this, we see that we have the difference of squares on the top. So we want to be able to cross that out. So, because if it's a parabola, then it won't be continuous for all real numbers. Most of them, but not all of them. And so we see that none, well, that probably wouldn't work. And so let's try if we substituted 1 in on the bottom, x squared minus 1, that wouldn't equal out either because you couldn't cross it out. Then 2, x squared minus 2, since you wouldn't be able to cross it out since 2 isn't a square of something, that can't be our answer. And then we see that 4, if you did x squared minus 4, that would be able to cross out on the top and the bottom, so our answer must be D. Alright, so for this question, we're finding the limit of x over the natural log of x as x goes towards 1. So to find the natural log, let's rewrite it first. So ln e then equals 1, since that's what we're going towards. And another way of writing that also is e to the what power will equal 1. And just because of our knowledge, we know that or any number to the 0th power will always equal 1. So we know that we have 0 on the bottom, and then x at the top. So 1 over 0, you'll end up with your answer, or your limit being non-existent. For number 21, we have to figure out which of these options, or how it is continuous. And so let's just go through the options for this one. So is this graph continuous at x equals -3? So -3 right here. We see that from the left it's going downwards, and from the right it's going up towards positive infinity. So obviously that's not continuous. Then as x goes towards -1, we see that we have a jump discontinuity, so that option is not continuous either. And then C, we see that as x goes towards 1, right here, that this is continuous, since there is no break in it, so that must be our answer. But just to check, we have our answer, or our last option, x equals 3, and we see that that one is not continuous since there is a removable discontinuity right there.